Good morning, good afternoon, and good evening, everyone out there. And welcome to the Friday Talk Show with your host, Rajiv Kulkarni. And I'm calling from Dallas, Texas. Yes, Central Standard Time. It's 9 a.m. on Friday, June the 6th, 2025. Yes, and we have today a special guest and based out here only in Dallas. And I say good morning, good afternoon, good evening because I don't know which part of the world you are going to watch this show. And wherever you are watching this, welcome to the show and thank you for watching and supporting the show as always. And first of all, I would like to welcome you um, and also I would like to thank all the audience and also I would like to thank the supporters who are supporting the channel by subscribing, by sharing the channel link and requesting people to subscribe the channel and also the supporters who have participated in our earlier talk shows. So global electronics main actually idea is to bring in the expertise from different field in the electronics manufacturing per se, catering to various market segments, whether it can be medical, whether it can be defense, automotive, consumer electronics, microelectronics, and so on and so forth, where the engineers can question the challenges they are facing in the electronics manufacturing. The people in the market, they can question about the market trend and the segments of the market they are dealing in, and so on and so forth. It's an electronic community service that Global Electronics is doing, through which this platform we are introducing different expertise to share their wealth of knowledge to the electronics community. Let's welcome today's guest. But before that, what is the topic we are going to discuss, right? We are going to discuss about automotive electronics. It refers to the electronic systems used in vehicles to enhance performance, safety, and convenience. You have seen there are like tons of electronics, as you can see in the display that is going on. Tons of electronics these days being used in the automobiles, right, that we drive every day. So these systems have become increasingly prevalent in modern automobiles, revolutionizing the industry. Yes, the revolution is there. There is a high speed network also in the automotive. There is high speed chips being introduced, the high density chips being introduced, because to transmit and receive the signals from one end to the other end, and so on and so forth. So automotive electronics, and there are certain what is automotive electronics, what are the key components, and there are challenges and future trends and so on and so forth. There are a lot of questions exist, and so in order to have a very interesting interactive session, we have Mr. Suman Nelluri, who has an expertise in the automobile industry for the last 3 decades and plus, and also he's now working for an automotive electronics contract manufacturing company here in United States. Let's welcome Mr. Suman Nelluri to our show. Suman, good morning. Welcome to the show. How are you this morning?
Good morning, Rajiv. Thanks for having me on the show. Good morning. It's a wonderful, beautiful day today, but thank you. Very happy to be
Yeah,
here.
yeah, excellent, excellent, Suman. And as you rightly said, yes, it is a wonderful day. And as we live here in Dallas, Texas, it's a sunny day, and uh, it's a Friday again, and everybody waits for the weekend. So, Suman, before we get on to just let's hear about your background, and so that the audience will know, you know, what's your background and so on and so forth.
Yeah, thank you, Rajiv. My background has been primarily come from a mechanical background, but I've been primarily in the automotive industry. Spent a bulk of time in Detroit working for Stellantis in multiple roles. So we have also been part of Stellantis, which was formerly known as Chrysler. Went through many changes. Part of those changes also is expanding globally. I was also
Hmm.
part of the team that helped establish Stellantis in India in 2007 and 8, and which has now become a very large captive center, I would say, for Stellantis. The biggest R&D center out of US, out of Detroit, is in India. That's based out of Chennai and Pune. So very, very huge capability. We do high-end work from India. After that, I spent a lot of. I left Chrysler in 2011 and spent the rest of the last part of 15 plus years in global automotive electronics, both taking not just manufacturing but taking any solution all the way from concept all the way to complete manufacturing of particularly primarily in the automotive industry, but we have also been in the industry agnostic sections. So, being there globally, I've spent a lot of time in India, building a lot of India competency, India design centers, primarily in the hardware, firmware, concept, product development space, which has been transforming very aggressively over the last decade. I mean, if you look at the electric vehicle industry, at least primarily the two-wheeler and three-wheeler industry in India, the exponential growth has been phenomenal, right? Whether you take Ola or Ampere or any of these products that have really ramped up, including the three-wheeler industry. So that formulates a necessity for many electronics products, that are required to be designed and developed. Some of them you cannot just take from the US or the European markets. You have to custom design for the Indian market. So I was also part of that development. So yeah, spent a lot of time in the global industry.
Okay, excellent background you have in the automotive industry. That's really great because that is what, globally the automotive trend has been going upward only. The trend has been upward, and vehicles are getting manufactured, vehicles are getting built these days more on the EV side of it. I would put it this way because more and more EV vehicles are coming. So what exactly is automotive electronics per se?
So, I mean, as you rightly indicated at the beginning of today's introduction, automotive electronics, I mean, primarily a vehicle, basically, it's a powertrain driven, takes from point A to point B, was how it started off. So you have over a period of time, I'll just take a step back and then describe over a period of time, automotive industry has transformed a lot. Okay. So you have powertrain that needs that's primarily was all mechanical gears system, etc., which has over a period of time transformed into a lot of electronics that drive those systems now. So powertrain electronics, you have safety, you have connectivity, you have, I mean, many of the body electronics that were mechanical in the past, whether it's windows up and down or lighting systems or any of the climate control systems have now all a lot of electronics into it. You have chassis control systems, you have, there's a lot of other systems that have been added because of the transformation. Primarily what happened was, in the 70s, what the automotive industry, which the Detroit, which was driving the global development, was all in the mechanical space, the IC engine space. So most of the innovation that drives everything was happening in that space, and the innovation at one point stagnated in the IC engine. So it kind of got stagnated and it went flat, and then the rest of the companies in the global world, whether European or the Asian companies, took over with respect to quality. So the decade of later 70s, 80s, and 90s, and the initial 2000s was all about transforming the at least the US automotive industry with quality, which transformed the rest of the world in terms of quality. Then what happened was the electronics industry with the advent of the microprocessing capability of the chips that really transform the most of the systems that are there in the automotive electronics have now been controlled and improved through the electronics. Now, one of the things that drives any change, one thing that happens in the automotive industry is they have adopted innovation for any change, right? So kind of innovation drives everything they do. And
Yeah.
one of the things that automotive industries have done very well is they've taken a systems engineering approach,
Hmm.
which many other industries are still catching up to. So they've applied the systems engineering approach. It's basically, if you look into the hardware or software development, it is a V model, they call it, where they seamlessly integrate all the sensors and the intelligent control units, or all the other softwares that come are need to be integrated to take complex challenges into smart solutions.
Hmm.
That's as simple as that. I mean, anything that you need to control, whether it's, if you're sitting in the seat and you need to control your seat back and forth, or you want a memory seat. I mean, these are all the things that are possible only because of the electronics, right? Memory seat, you can, I mean, if you go into any of these luxury cars, you can select option one, seat memory two, seat memory three. This was only possible because of the electronics innovation that happened in the electronic space.
Yeah.
But innovation drives everything, and it's still happening. And then I'll take an example at one point before we on how innovation is driving the future in the automotive electronics. I'll take an example of a camera system and
Sure.
explain that. Yeah,
You want to
Go ahead,
share
Rajiv.
any? You want to share any screen? No, right? Okay.
No, no, no.
Okay, okay, okay. So that's fantastic, explanation about automotive electronics, what you mentioned. So what are the key components, in the automotive electronics?
I mean, key components, if you, I
Like,
mean, there's.
like driver assistance, engine electronics, and
Oh,
so on.
yeah. Okay. So, yeah, I'll categorize them into four areas. The fundamental ones are controls, right? I mean, you have powertrain controls, you have performance controls, you have body control mechanisms, you have thermal controls, you have some monitoring systems, and security and access controls. So, these were controls that were previously mechanical, are now done through electronics. So basically,
Hmm.
controls are your primary functions that were there, which were mechanical, are now done through electronics. So that is a necessity. That is not I wouldn't call it, it's a uh, nice feature or a luxury feature, but it's a necessity. But slowly, most of the other features are also becoming necessity. And then there is driver assistance systems. There are many driver
Hmm.
assistance systems that allow vehicles. I mean, I mean, pretty much every vehicle that is sold out there has a level of driver assistance. It could be simple driver assistance where cameras allow you to look in the while parking, etc., to multiple driver assistance systems. Then you have connectivity that, whether it's, telematics, whether it's cloud infrastructure, or if you need cyber security. So many of these connectivity are also possible now because of the mobile app that you can connect to. Then you have anything that's electric vehicle, you have the other battery management systems or charging management systems that are there. But primarily, I'll just simplify into four areas:
Sure.
controls, driver assistance systems, connectivity, and then if the vehicle is hybrid or electric vehicle, anything that are associated with the electric vehicle that are there.
Okay, excellent. Let's take a quick break here and let's see this video and come back.
Sure.
Good morning, good afternoon, and good evening, and welcome to the Friday talk show, Global Electronics, with your host, Rajiv Kulkarni. I'm based out in Dallas. Today, we are talking about automotive electronics, and we have an expert from the industry who has more than 3 decades of experience in the automotive industry, Mr. Suman Nelluri, who is also based in Dallas. So we have been talking about what is automotive electronics, what are the key components so far, and so welcome back, Suman, after this small break. And now heading to the next one here, what I have a question is what are the emerging technologies in the automotive electronics? Like automation, or we talk about connectivity, as you mentioned,
Right.
these, yeah.
And
And
I mean,
these
that's
days,
the
AI is one of the big trending thing
yeah,
is
right.
happening. So, yeah.
Absolutely. I think I would one area that's at least in the last year and the next couple of years, I see a huge transformation that's happening. I would say, in the camera or the vision technology, and that is allowing a lot of innovation that is happening in the ADAS space. So, when I say ADAS, it's Advanced Driver Assistance Systems, which most of the vehicles allow the driver to be able to uh, do things that were not possible because of the technology. I mean, I would say I would give one example. I'm going away from the automotive industry, but people who are health conscious,
Uh-huh.
they were at one point 5 years back were thinking, hey, if I was able to take whatever I'm eating, right, if it's rotis or a burger, whatever, if I was able to take a picture and then have some intelligence at the back and tell me how many calories it has, how many fat calories, etc., it would have been nice. It's a nice vision. It would be nice to have, but technology wasn't ready for that, right?
Mhm.
For today, 5 years later, it is possible because of the technology. And what is the technology innovation that happened? One is the camera vision systems that has allowed you to do that. And then the microprocessing capability. I mean, the companies like Qualcomm, etc., have really transformed, the processing capability of the data, right? You'll have to be able to process whatever. So, most of the innovation in the future I see happening, at least in the near future, yeah, which is already happening today and the next couple of years, is in the driver assistance systems and anything that is related to camera and vision based.
Mhm.
Mostly because the technology is changing very rapidly and the processing capability is changing very rapidly. Um, Whether it's a simple thing like, if you want to be able to detect somebody is sleeping while driving, and then you want to be able to alert the driver or send an alert to over the air, send an alert to one of your family members. It would be a ni- it was it's a nice to have, but today because of the camera capability, because of the processing capability, and because of the ability to the connectivity that is there, you're able to do all these things. So I think drastic some of the innovation will happen in that space.
Okay, great, great. So now, what is the what like importance of automotive electronics? I mean, the electronics has put us into for example, ADAS is definitely calls for, I think, safety, being having those sensors and all, right? So,
Right.
I mean, I would consider that is one of the categories of importance of automotive electronics. And then definitely, I don't know. I mean, performance maybe is another enhanced
See,
performance.
one of the biggest challenges in the automotive electronics is, with so many possibilities, and so many permutations and combinations that happened with, you are adding so many features in a vehicle, which was not there 10 years back.
Yeah.
So many features and so many combinations of those features. So testing and validation becomes very critical of these
Big challenge.
features.
Yeah.
It's
Yeah.
a big challenge, and also many of these changes are happening at a very rapid pace, right? At a very
Hmm.
rapid pace, and you want to be able to test and validate. So there's a lot of hardware. I mean, there's again software in loop testing, hardware in loop testing. Um, Previously, mechanical testing, you're able to physically test some of these products, but right now the permutations and combinations you can't test all. I mean, there's some permutations and combinations can go into millions, so you won't be able to test all every case. So
Points. Yeah.
the hardware in loop testing before you actually launch it out becomes critical, and also with respect to anything that has functional safety requirements or a cyber security requirement also becomes critical.
Correct. Correct.
That's another space that is also rapidly evolving. There's another challenge that many of the electronics design companies face is, as they keep adding electronics, as they keep adding components, anytime you want to add a feature, anytime you want to add a good to have, you add electronics, but then the space and the power that goes through the system remains the same. I mean, your module size does not, you really don't have, I mean, every year your module reduces but doesn't increase, right? But
Yeah.
then you're running the power that goes through through the electronics remains the same or increases because of you're adding more. So, thermal management becomes very critical.
Hmm.
And that's from a design perspective, not a manufacturing perspective. Thermal management is a big challenge, and that is a skill that would be required uh, more and more, at least in the near foreseeable future. Skills with able to be able to predict, test, validate, and also improvise. What can be done in rerouting some of the electronics or finding different components to actually manage the power flow through the electronic boards.
So it's the thermal management. You brought up a very interesting subject. That's a very interesting for me too. And definitely, thermal management demand or trend will start increasing because of the, I think, high density circuit boards or high density chips which are being manufactured,
Correct.
for the because of high power devices, right? And which would continuously start generating the heat because of the usage of those system in the automotive, you know, assembly or so on and so forth. Yeah, you're right about that for sure. And so, what do you see the challenges and future trend? You mentioned a couple of challenges already, but the trend
So
in
if I can take a minute, Rajiv, and I mean, I
please
work
do.
we at I'm with Navtech Electronics is a company that's based out of Detroit. We also
Okay.
have an office in Atlanta, Dallas, and back office, major office is in Hyderabad, India. So we to one of for the hardware in loop testing, one of the products that we have developed, custom developed, and now it's being used by BMW and a large OEMs like Magna and other battery manufacturing companies. What we do is, anytime you test, you have to test in multiple scenarios. You want to be able to make sure that your module performs in Arizona
Hmm.
in July, August. At the same time, is able to perform in Colorado in a
Yes.
elevation at minus 40 degrees Fahrenheit, etc. So our your traditional testing does not do that. Your traditional testing does it at ambient temperature, plus or minus. So we have custom created these stress testers that perform that simulate these conditions. Even you don't have to go to Arizona, you don't have to go to Colorado or any of these cold spaces, but you will be able to simulate those conditions wherever you are. So that's in high demand, and that's how we have adopted. Coming from the automotive industry, we have adopted innovation as our primary driver. We take innovation, and what we do is we take innovation to solve complex challenges into smart solutions, uh,
Hmm.
and at a lightning speed. That's primarily what we do. And any challenges, all you need is, the right solution. So this is one of the challenges that we have taken up and provided a solution. And leading on to that, you mentioned other challenges that might be there. I think
Before that, we have a question here. When we say automotive, what is the difference between regular vehicle and off-road vehicles applied to electronics?
so. I mean, when you have an off-road vehicle, all you are adding is, your powertrain and chassis capability is increasing because off-road you want to be able to, be able to go in a rugged terrain, right? And
Mhm.
there are mechanical features that allow you to do that, whether it's your your uh, mostly it happens in your chassis is where you need your electronics to be able to control, right? I mean,
Right.
if you need two different tilts, axle tilts that you need because of the rugged terrain, your electronics must be able to sense what you need. So you need strong sensors that will give immediate feedback and what needs to be changed and be able to control to be able to have your chassis controls to be able to make those control and adjustments. So it allows you to do more because of what was previously done through only limited mechanical capability. Now with your IoT devices, which your sensing capability, your processing capability, and your control capability, and the speed with which you can control, you're able to do more with your off-road capability, which you will probably don't need. So some vehicles that you buy comes with both options, right? You're able to come off-road capability. You're able to switch off and on. If you're going on normal roads, you're able to take that mode.
Right.
And with same vehicle, if you're going off-road, you can choose the other mode, which will activate the sensors, which will activate the system or the modules which
System.
will be dormant otherwise.
Okay, great. So I hope that answers your question. And also one more comment, ABS bracket systems are electronics. Okay, that is right. And also the airbags too. So that's a good comment there. So yeah, I was talking about the challenges and future trends. And I think we are almost through getting close to our timing, but I think this question and whatever then you have comment to our audience, you can do that, Sumat. And just for the audience, today we are talking about automotive electronics. We have an expert from the automotive industry, Mr. Suman Nelluri. He works for Natec Electronics, based out in Detroit, Atlanta, as well as in Dallas. They have a back office in Hyderabad in India. That is the southern part of India. And they are one of the key suppliers for automotive industries on the contract manufacturing side. Yes, Suman, please continue.
Thank you, Rajiv, and thank you, everyone. Again, key challenges we already touched upon. Many of them, the complexity of the systems, and then as more and more features keep adding, the integration becomes a challenge. Along with that, with all the telematics and over-the-air updates, etc., you got cybersecurity risks that needs to be managed, and obviously you got functional safety that's important. We already touched upon thermal management. I think with the recent uh, advent, at least in the last 2 years, and now supply chain becomes, I mean, through COVID, we have seen one of the bigger challenges is supply chain,
Yeah,
which the companies are adapting. Many of them, particularly from the manufacturing standpoint, are adopting. Till the COVID time, everybody were just in time, just in time, just in time, and they had limited inventory, and it
yeah,
was all they saw value in just in time. So nobody
yeah,
kept inventory, and then it was all the supply chain was so optimized. There was so much value added, value chain capability. It was optimized, and so limited inventory everywhere. There was no wastage, but it was so simple and optimized. They were able to manage it. But with COVID, it changed everybody's perspective. Now
yeah,
you've got everybody reorganizing their thought process and restructuring how things are done or how things are ordered. So supply chain will definitely be a challenge with the tariff situation. Definitely, it opens up new opportunities if there are obviously companies that are different geographies that also opens up opportunities that can pick up the challenge and build the capabilities to take up these new opportunities, definitely. So supply chain challenges, I would also say at the same time, it opens up opportunities.
Yeah. And one more question has come up, the issue of automotive harnesses arriving charged by static electricity and potentially causing damage when connected to electronic units. Is this an issue that automakers are taking into account?
I think that's a very good question, and I may not know the 100% answer. What I believe is, mostly that's a risk that comes from manufacturing capability. If harnesses are
Hmm.
built without electronic compatibility, if they're not taken care of that, then you'll have this static when they come into production. From a design standpoint, I'm not really aware if that's a concern. But from a manufacturing standpoint, if harnesses are manufactured at are not a qualified or tested electro compatibility capability manufacturing facilities, then it becomes a concern, and that has to be addressed. I mean, you got to ensure companies have to ensure that most of the automotive OEMs are make sure that that system is addressed. But from a design standpoint, I'm not really sure if that's a concern.
But I also believe that when you have this harness manufacturing processes or any for that, you have the ESD, setup, right? Like you to avoid all kinds of these kind of static issues. And when the products are manufactured, there's already the ESD testing stations and the station itself. I mean, the tables and everything, they are all ESD compatible things, and maybe there is a possibility that in some cases it might just get ignored, or maybe land up in the automotive
I
sector.
mean, that's why it is important that wherever the harnesses come from are vetted and
Properly.
high
Yeah.
standard supply base who are already evaluated for that capability. I
Yeah.
mean, manufacturing suppliers should be qualified for sustained production
Hmm.
capability, not just one time capability.
Yeah. Right. Okay. That's a great answer, and I think we are already through the time. Suman, anything else you want to convey to our audience before
No,
we
no,
leave?
thank you, Rajiv, for having me on. And then for the audience, thank you, everyone. And this is, again, simple word I'd leave with is there's so much innovation happening. What we talk about today, I think 2 years from now will be a drastic change. But one
Change.
thing I can say, things that were imaginable but were not possible because of technology and are now that gap is no longer is being limited. I mean, whatever can you can imagine is pretty much being able to be done, designed, developed, and produced because of the technology development that has happened, particularly with the advent of electronics, camera-based systems, processing capability, etc.
Excellent, Suman. Thank you very much for your time today. And we wish you good luck in your business, automotive business. And thank you all for watching the show. And definitely you can watch it later also. It will be there on our YouTube channel, available anytime that you would like to watch. With that said, thank you all. And wherever you are, whichever part of the world you are, please take care of yourself in good condition, and let's meet next Friday with yet another topic on Global Electronics Friday Talk Show with your host, Rajiv Kulkarni. Have a wonderful weekend. Thank you. Bye.
Thank
God bless.
you. God
Thanks.
bless.